All right, guys, welcome to partial fractions and the method of using partial fractions. So this is the part one of a video series that we're going to do on using partial fractions to integrate certain types of integrands, okay? So the case that we're going to talk about today is the proper rational function, p of x over q of x, and q of x factors into linear factors. Okay, and by proper we mean that the degree of p of x is less than the degree of q of x. Okay, so what we're talking about is the decomposition of p of x over q of x, and those are polynomials, into partial fractions. So you got to think about decomposition of partial fractions today. So in this video we're going to specifically look at this case, and there's other videos we're going to look at where p of x over qx is not proper, and some other methods, all dealing with partial fractions. So we're just looking at this specific case in this video. So my strategies are going to be, number one, I'm going to find the partial decomposition, and this includes finding a, b, c, maybe d. It depends on how I can really break up my fraction, how many factors I get in my denominator. Okay, and so once I have the partial decomposition, then I'm going to integrate that. So the idea here is the partial decomposition of rational function that's proper is going to break down into a over x minus a, b over x minus b, a c over c over x minus c, and you could keep going on into, you know, whatever letter, so letter over x minus that letter, okay, and they see it, and it just keeps going on, depending on how many factors you have. Most of the time we're going to stick between 2 and 3 on these partial fraction decompositions. So let's look at these strategies. Okay, so in example 1, we're going to integrate d of x over x squared minus 7x plus 10. So the idea, the first thing I want to do is try to factor q of x, factor the denominator. So I just rewrite it here, and underneath I'm going to start from here down is the partial fraction decomposition. So notice there's no integral sign right now. That's the first step. I've got to find a partial fraction. So there's no integral. I know that I can factor the denominator to x minus 2, x minus 5. So that means I'm going to have a is going to be associated with x minus 2, b is going to be with x minus 5. So the idea is like a, b, c, keeps going. Okay, you start with a. So this is what we're going to do. There's the partial fraction decomposition definition. The goal now is to find a and b, and once I find a and b, then I can integrate. Okay, so we don't like fractions in the denominator, so I'm going to go ahead and clear the denominator by multiplying by x minus 2 times x minus 5 to each side. So when I do that here, I get 1. When I do that here, remember the x minus 2 is going to cancel with the a, so you're just left with a times x minus 5, and b is going to get the x minus 2. The idea on this side, it becomes a common denominator, really. That's what's happening here. So, so this is what you'd have to multiply a by. It's like saying a times this, b times this, and that's what we get here. Okay, so I have a nice little equation here. I can use that to find a and b. Now, to find a and b, it's really like pretending they're the x and y intercepts. I'm going to set one of these variables, really try to equal 0, and find the other one. Now, I can't just say, well, b is 0. Notice that b is being multiplied by the x minus 2. So, to find a, I'm going to let x equal 2. So there's that equation, the 1 equals a times x minus 5 plus b times the quantity x minus 2. So wherever there's an x, I'm going to put 2. So I go ahead and put 2 here, and notice b times 2 minus 2 is 0. That's gone. That's eliminated. So I'm left with 1 equals negative 3a. Solving for a, I get a equals negative 1/3. So now I want to find b. So I need to get this a term to be 0. So I'm going to let x equal 5 now. So there's my equation. 1 equals a times the quantity 5 minus 5 plus b times the quantity 5 minus 2. So wherever there's an x, I'm plugging in 5. Now 5 minus 5 is 0. A times 0, that's gone. So I'm left with 1 equals 3b. So I know that b equals 1/3. So the partial decomposition, 1 over x minus 2 times the quantity x minus 5 equals this. There's the partial decomposition. That's what I'm going to integrate. So if we shift up, there's where my integration is, negative 1/3 over x minus 2 dx plus the integral of 1/3 over x minus 5 dx. So this is just integral properties separating the two. Now, notice what I did in red. I swung out the negative 1/3 and the 1/3 out front, and I'm taking the integral of 1 over x minus 2 plus 1/3 integrating 1 over x minus 5. Using u substitution, okay, I can find out, and notice we'd have a 1 over u, 1 over u. So using u substitution, these integrals become natural logs. So when I integrate this finally, I get negative 1/3 times the natural log of the absolute value of x minus 2 plus 1/3 natural log of the absolute value of x minus 5 plus c. And that is how we use the method of partial fractions to integrate a particular integrand. Okay, so that's our first example. Let's look at one more example very similar to this. Okay, so in example 2, we're going to integrate x squared plus 2 over the quantity x minus 1 times the quantity 2x minus 8 times the quantity x plus 2 dx. Great, I don't have to factor like I did in the first example. My linear factors are already there. So here's the partial decomposition right here, that definition. I have 3 factors in the denominator, so I'm going to have a, b, and c. A goes with the first one, b, and c. So here's the partial decomposition definition. Clear out the denominator, this time by multiplying not by 2 terms, all 3 factors in the denominator, 1, 2, and 3. Notice if I multiply this left side by the denominator, we're just left with x plus 2. Now, here's the catch. Basically, A is going to get the other 2 the denominators. Okay, B is going to get these 2, C is going to get these 2. Because if I multiply this side by the entire denominator, if I multiply this by this denominator, the x minus 1s will cancel, I'll be left with just these 2. So here, after I multiply through by this denominator is what I'm left with, this long equation. Now I got to find a, b, and c again by letting, or getting 2, in this case, 2 of these variables to equal 0. So when I look at a, I want to find a first. Okay, I know that a goes with the factor x minus 1, so I'm going to let x equal 1. So if you look at that, notice what you see here, x minus 1 and x minus 1. If x equals 1, b and c is automatically eliminated. I don't even have to plug it in. These are gone. I'm just left here. And that's what you see in blue. Because 1 minus 1 is 0, 0 times anything is 0. These 2 terms are gone. So I plug in 1 for x. I'm left with 1 squared plus 2 equals a times 2 times 1 minus 6 times 1 plus 2. So that's negative 6 times 3. So I get negative 18a equals 3. So a equals negative 1/6. So I found my first variable a. I got to find b and c now. So I show you the example of how to do b. So b is associated with the 2x minus 8. So to make that 0, x would have to be 4. Okay? So that means the a term and the c term are going to cancel out because they both have that factor 2x minus 8 underneath. So if I want b, a and c are going to be eliminated. So I have 4 squared plus 2 equals b times 4 minus 1 times 4 plus 2, which becomes 3 and 6. So 18 equals 18b, so b equals 1. Similarly, I can do with c. c is going to be associated with the x plus 2. That means I'm going to let x equal negative 2 here. The a and b terms cancel. I'm left with c. I end up getting 1/6 for c. So here's the partial fraction decomposition. This right here is what I'm going to integrate. So I go ahead and write that there. I'm integrating all 3 of those. Just like the previous example, I pull the, well, in this case I pull the 1/6 and the negative 1/6 out front, which I do here. So I'm negative 1/6 integrating 1 over x minus 1 dx plus 1 over 2x minus 8 dx plus 1/6 integration of 1 over x plus 2. All these would be u substitution, where your u would be the denominator. So I'm left with negative 1/6 times the natural log of the absolute value of x minus 1 plus natural log of the absolute value of 2x minus 8 plus 1/6 times the natural log of x plus 2, that absolute value, plus c. So those are 2 examples of partial fractions using the method of partial fractions to integrate. Again, we were talking about proper fractions where that denominator can be factored into a linear factor. In the coming videos, you'll see several different things that happen with p of x over q of x. So if you guys have any questions or comments, go ahead and type them below, and we'll see you next time.